All right, hello students. Today we're moving on with lesson 12. We're going to use distributing expressions. So we're going to kind of talk about the distributive property and distributing expressions. Excuse me. All right, so here it says opening exercise. Here it says create a model to show 2 times 5. Well, we kind of talked about this in the previous lesson. 2 times 5, we can draw a model as um, a box here, and this could be a 5. And because we need another one, we want to try to draw it about the same length, but of course this is a drawing, it's not going to be perfect. And this is 5. So we have 2 5s. This is known as 2 times 5. So this is a model of simply 2 um, times 5, or 2 5s. So next we can kind of take the same idea, but now we're going to use a variable. So it's the same basic concept, except now instead of having an actual number, we have a variable. Well, the process or the concept is the same. We have one box here that's labeled B, and we have the same kind of box. Once again, it's not going to be perfect because we're using a sketch. It's going to be B. So once again, this represents 2 times B because there's just simply 2 B's. And of course, that's why it's written that way. This just simply says 2 B's. It's like saying you have 2 pencils. I don't say 2 times pencils. I say that you have 2 pencils. Same basic idea when it comes to variables and numbers. This is 2 times 5 or 2 um, and 2 times b, 2b. So same basic idea. All right, so now if we come over here, it says write an expression that's equivalent to 2 comma ab. So this is 2 times ab. Well, we're going to kind of go through this kind of using models. We can kind of step by step using models on how we come up with this answer, how we come up with an equivalent expression to this. So kind of all the work that we're going to do here in example 1 is going to come up with an equivalent expression to 2ab. So here it says create a model that represents a plus b. Well, so it's kind of like before. We have a box here that's represented by a, and we have another box here, maybe even a different size box that's represented by b. So here we go. Here's a model of a plus b. Well, now since the expression is 2 times a plus b, tells us that we have 2 of these. So now we're going to create a model that says we have 2 groups of AB. So what we're going to do is kind of copy down what we have here. So we have one group of A, one group of B, and now we're going to kind of just do that again. So we have 2 of them. So here's another A. Oh, that wasn't very close to the other one, but that's okay. Once again, this is just a sketch, an idea to kind of show what we're doing. And there we go. We have a B. So once again, now it says how many A's and how many B's do we have in the diagram? Well, we can count this. There's one A and there's 2 A's. There's one here and one here. So here we have 2 A's, also known as 2A. And here we have 1 B, 2 B. So there's 2 B's, or 2 times B. All right, so if we continue kind of to work through this, it says, how would you look if if you group the A's and you group the B's together? So now our model, we're going to kind of take the same thing, but now we're going to put the A's together and we're going to put the B's together. So here we have A, one A there, and another A here. And now we're going to group the B's together. So next to the A, we're going to have a B, and next to that B, we're going to have the other B. So there you go. So we have 2 A's here and we have 2 B's here. So now it says to write an expression that could be represented by the new diagram. So what we have here, kind of very similar to what we had before, we have 2 A's plus 2 B's. All right, because there's 2 A's here, so 2 times A, and there's 2 B's here, so 2 times B. And of course, we're adding them together because they're all connected. So now it says, what conclusion can we draw based on the equivalent expressions? So based on our kind of starting off point, where we were going to write an equivalent expression to to A plus B. If we remember this, I think from last slide, yeah, right here, we're going to write an equivalent expression to A times A plus B. So what can we say? This right here is equivalent to the 2A plus 2B. This is known as the distributive property. What we're doing is we're multiplying the outside number by both of the inside terms. So this would be 2a plus 2b. And so there you go. So that's kind of our breakdown of how we can turn this, use the distributive property, and create this simplified expression. Um, so that's kind of a breakdown of kind of what we're doing and how it's kind of being represented. All right, so go ahead and stop the video and go ahead and move on to the next example. All right, hello students. Now we're going to move on to example number 2. So we're going to kind of take the same basic concept we talked about before, but now we're going to kind of do it some different type of an expression. And so let's go ahead and get started. I did skip a little bit here. I will skip a little bit in here, so don't be surprised if it doesn't flow kind of with your page. Just go ahead and I'll kind of show you or tell you where I skip. It says write an expression that is equivalent to double. So we're going to double 3x plus 4y. So they want us to go through the models like they did before, but we're not going to do that. And we kind of took the time and went over the models before and the other one. This one we're kind of just going to take kind of straightforward. So it's how can we rewrite double this? Well, remember the word double, if I say you're going to double something, it means we're going to multiply it by 2. A double means to multiply something by 2. So based on what we talked about in the previous lesson, we're going to go ahead and we're going to double this. So we're going to multiply it by 2. So 2 on the outside, and it's going to say 3x plus 4y. So this is doubling it. Now we could have written this twice. We could have written 3x plus 3x plus 4y plus 3x plus 4y, or double really means just simply to multiply by 2. So now what we're going to do, it says, what is an equivalent expression that you can write, that we can use to represent what we just wrote, the 2 times 3x plus 4y. Well, here we can actually do the multiplication. We can actually take the time and multiply it out. So remember, when we have this expression, 2 times 3x plus 4y, this is known as the distributive property. So what that means is we have two 3x's, so 2 times 3, which is 6x, and then this means we have two 4y's, so bring over the plus sign, means 2 times 4 is 8, and the y stays the same. So there we go. This would be the same representation of what we have up here. We just simplified it down. So here it says summarize how you would solve this question without a model. Well, we kind of just did it. I skipped the model portion of this. As you can see, you have quite a bit of more information between these two questions. I skipped the modeling portion and kind of just went through the process. We did the model before. I didn't see a reason to do it again. So what did we do? We just simply multiplied the outside number. Well, let's kind of go a little more technical. When there is a little more detail, I should say, a number outside the parentheses, I would multiply. So what did I do? I multiplied the 2 times both numbers inside, or both terms inside. I would multiply, oops, that's not spelled right. Let's try that again. I would multiply it by all the terms on the inside of the parentheses. And that's what I did. I just simply took the outside term, or in this case, the outside number, and multiplied it by both terms on the inside. Remember, 2 times 3x is just 6x. 2 times 4y is 8y. All right, so that's kind of a summarization of what we did. And we didn't use the model. We kind of skipped that portion because we did it before. All right, so if we look at this, here's kind of another diagram that I like right here, is we're going to kind of take the same basic idea, but now we're going to use kind of a different model. Well, here, it says rewrite the expression in expanded form. This is equivalent to model below. Well, I want to kind of show you what this would look like as a problem itself. So this would look very similar, or this would look like this, before we kind of do the multiplication. So this is saying y times 4x, y times 5. And so here's kind of another way you can kind of break it down. Whenever you see the addition sign, it's kind of separating out the terms. This is one term, this is another term. The y must be multiplied by both of them. So if we go through kind of the go through the process, it says y times 4x. Well, that's 4 in the box here would be 4x, and then times y. Remember, we want to put them in alphabetical order. And then y times 5 would be 5y. And remember, this is just simply a plus sign. The plus sign kind of just comes straight down. All right, it says what factor, sorry, right here. What factor expression can be represented by the model? Well, I kind of gave it away up here. Y is kind of part of both of them. So y would be on the outside, and this would be 4x. So I kind of gave you the answer to this before. Have in common, and of course the y is what they have in common because it's right there. And it says, how can we rewrite the expanded expression? Well, we did it right here. This is the expanded expression for xy. I said a almost there for a second, plus 5y. So as you can see, what's in the boxes here is the expanded expression, the equivalent expanded form. So this is known as a factored form where they take out what's in common. They both have y, so they took out the y. This is the expanded form because we actually did the multiplication. There is no parentheses and no multiplication to be done. All right, so that's kind of another way of looking at it. And if you like this box here, please use it. I think it's a great tool. All right, so go ahead and stop the video. We're going to move on to one more video where we can kind of go over some more examples of the distributive property. All right, hello students. So on this last video, we're just simply going to apply the distributive property and rewrite the expressions in expanded form. So we're just going to apply the distributive property to all of these. So if you like to, or I would like you to at least try to pause the video and try these on your own, and then come back and I'll go over the answers and see if you come up with the same answers I have. So you can always try it do one with me, pause it and try it kind of as I go through them. All right, so on this one, remember all you're going to do is multiply the outside number by both inside numbers. So 8 times h is 8h. And then 8 times 3, remember for the plus sign, is 24. So there you go. I mean, that's the distributive property. So we're kind of doing the opposite of the factoring out. So we did some factoring out of the kind of greatest common factor. Here we're kind of putting it back in. So here on number 4, I'm going to kind of show that table again, that little box table. So, it doesn't have to be perfect. There's a little sketch. I have 2 terms. I have 2h, so I put 2h up here, plus, and then I have 7. So here in the boxes, I can do the multiplication. 3 times 2h is 6h. 3 times 7 is 21. So in the boxes, I'm just simply bringing them over. So this is, if you like to use this little model here, this is a great model to use to help you kind of keep everything organized. Perfect for what we're doing here. If you just did the multiplication, this is 3 times 2, which is 6. 3 times 7, which is 21. I just brought over the h. Notice the h is in the first term, h in the first term. So if you like to use this model, feel free to use it. Perfect. Don't worry about that's a great tool to use. As we move down here, so kind of the same thing, 5 on the outside. I'm going to multiply it by both of the inside terms. So 5 times 3x is 15x. 5 times 3 is 15, and the x just kind of just sits there. 5 times, plus sign. 5 times y is 45. And then the y gets brought over. Remember, they're being multiplied. And there you go. I mean, that's it. This is your answer here. Go to the last one. 4 times y. Sorry, 11h. I said y, excuse me. 11h is 44h. And then we're going to add to it 4 times 3, which is 12. And then g. So there you go. All right, so there are the answers. Hopefully you gave at least a couple of those a try on your own and kind of check to make sure you were doing it correctly. Remember, if you like to use this model over here, please do. It's a great model to use to help kind of keep you organized. All right, so you can go and stop the video and you should be able to go and get started on your assignment for the day.